We'll get started in 30 seconds. Well, good morning, and thank you for joining this webinar on instrument transformers. We're going to go ahead and get started. We have a very large group on the call, so we are going to keep everybody muted in order to just sort of keep the presentation going. However, if you have questions, if you have comments, use the chat feature. That's probably the best way to go. So I can get your feedback and questions, and we will have a time at the end for questions as well. This is being recorded, and we will send out the recording to everybody, so you'll have a chance to share this with maybe others in your utility who couldn't make the presentation today. So that's our plan. So we'll go ahead and get started. We've got a good group. My name is John Rennie, and I am the co-founder and CEO of Peak Demand. And Peak Demand is a manufacturer, designer, builder of products for the electrical distribution side of the house. So, and let's see here if I can get my slideshow working. There we go. So this is who we are. We're based in Wilson, North Carolina, and we were founded by a group of industry veterans. We all left large companies in the industry to start this business, mostly because we were frustrated with what was happening in the big companies. So lead times were long, costs were high. I think that products had been cost reduced to death. So we wanted to make a difference. So we started this company nearly 5 years ago now. So we have designed, we test, and we build our products here in the USA, and we ship all over the country. So, and many of you on the call are our customers. Some may not be, but we welcome you all here for this training. So I would say too, the other thing is we're open in the middle of this coronavirus. We are open and we're running at 100% capacity. So if you need anything, we are here and ready to supply. So we are going to get started talking about instrument transformers, one of my favorite subjects. First one thing real quick. Some of the products we offer here at Peak Demand: fuse cutouts, distribution switches, insulators, metering CTs, and we do a number of OEM products like switchgear CTs and bushing CTs, and different types of components. But the main thing, metering CTs, fuse cutouts, switches, and insulators are our primary products right now. Okay, so we are going to get into instrument transformers. So what is an instrument transformer? The basics of a CT, how we apply them. We're going to get into the standards. We're going to talk about standard range, standard accuracy CTs. We're going to talk about high accuracy CTs. We're going to talk about why you want to use high accuracy CTs and what advantages they may have. But one of the main things that I hope you walk away from this training is taking a look at a CT nameplate, and I'm going to show this up on my video here while I have a CT. But one of the things is you have these nameplates, and these things can be a little bit confusing. We're going to walk through everything that's on a nameplate, so you'll be able to quickly walk up to any CT anywhere in the world and be able to tell exactly what it is and how it's used. So hopefully by the end of this, you're going to have that knowledge. So the first question is just, what is an instrument transformer? And it's pretty basic, all right? So the purpose of an instrument transformer is essentially to take high levels of voltage and current and bring it down to a safer level that can be used for measuring and or protecting. And so it's done in a very accurate way. So there is a ratio between the primary current and the secondary current, and that is done in a very linear fashion and a very accurate fashion. So what you're doing is essentially just taking high levels of current voltage and bringing it down to a lower level of current voltage so that you can measure it. That's all that a CT does. And so your applications are going to be in mostly your higher current applications in the utility. So we'll talk about a few different types of CTs that you'll see, like the one I have in my hands right here. This is typically you're going to see this in metering cabinets. A lot of times they'll have a primary or have a bar on there. Sometimes they don't, sometimes they have base plates or not, but typically these are used in CT cabinets or metering cabinets, excuse me. The style that you see here, they're a little bit larger. These are typically mounted for overhead applications. You see these a lot up on poles next to commercial installations where you're measuring your current for metering applications. Then you have some that are actually used in pad mount. So specifically, I'll talk about this style. So typically you'll see these have like an oval window because they're going to slide over the primary bus that you're going to see inside pad mount gear. And one of the ways that you can tell, and we're going to talk about nameplates, why this is or you can tell it's a pad mount CT, mostly because they're almost always rated at 85 degrees Celsius, because typically you're in a higher temperature environment when you're inside a cabinet like this. So you're going to see these typically rated at 85 degrees. So we'll talk about that when we get into rating factor discussions, but just remember that these are a special type of CT, and you can tell what they are just by looking at the nameplate. You'll be able to tell. Then we have some larger window CTs, and our company and others provide various different window sizes because of different applications that might have you. These are a little more unusual. You don't see these as much, but typically when you're trying to handle larger currents, you have multiple cables, and so these will have different size window openings. So there are various different sizes of these in our portfolio, and as well as all the other suppliers in the industry. The other thing you'll have, and we're not going to talk about primary metering as much today, but primary metering is also another way that we'll measure large commercial and industrial sites. So these are 15 kV and above applications, and typically you'll see a cluster mount of CTs and PTs measuring a large commercial site or a large industrial site. And these are a little more unusual, but sometimes you'll see slip-over CTs to measure current when you might have a tie point between maybe two different entities, and you want to measure power and make sure that you're checking that power between the two entities. So sometimes slip-over CTs are used. But we're not going to talk about that as much today as either. So CT basics, what we're going to talk about today is we're going to key in on the secondary metering 600 volt CTs. So if you look at the different style CTs, you'll have your low voltage CTs, you have medium voltage, this is your 15 kV, 5 and 15 and above, and then you have your high voltage CTs, and these are typically used in substations, 69 kV and higher. That's on the higher end. But what we're going to key in on is secondary metering, because that's probably the most common that utilities will be using. You'll see a lot of these applications at your utility, depending on how much commercial business is in your area. So the one thing I want you to come away with is to look at this nameplate that you see below. And this is just an example of one of our nameplates, but every every manufacturer in the industry has this very similar format on nameplates. So we want to be able to give you an understanding of what all the things are on this nameplate. So you can look at this nameplate quickly and identify what you've got for a CT. All right. So we'll start off right here. So there's 10 different things on this nameplate that I want you to understand by the end of this training, and so that you can quickly walk up to a CT and know exactly what it is. Now, I will tell you this. I am an engineer, and by nature, engineers take the simple and we make things complex. And that's one thing I noticed when I first came into this industry, is that we made these nameplates a lot more complicated than they need to be. So hopefully you'll get an understanding over the next 20 minutes or so that this stuff is really simple. What's on here is really important, and it's actually really easy. But the way they've kind of set it up, it can be a little bit confusing. So we're going to walk through that and try to make the confusing simple. All right. So let's take a look at the first thing on here. We've got what I've got circled here is NSV 0.6 kV. all right? That is an engineer telling you that is 600 volt CT. All right, so NSV is just your nominal system voltage. 0.6 kV is just 600 volts. Why they don't just put 600 volts, I don't know, but that's what you're going to see across the industry. NSV 0.6 kV. So there, right there, you know, you've got a secondary metering CT, 600 volt. Good, that's a good piece of information to know once you pick up the CT, all right? Going into the next item on the nameplate, we're going to talk about probably one of the most important things about the CT, and that is your ratio. A ratio is your linear relationship between your primary side of the CT and your secondary side. So in my example I have here, right, your primary is going to be running through the CT. So this is your primary current, and your secondary current would be coming off of your secondary leads, all right? And so there is a linear relationship. In this case, it's a 500 to 5 CT. That means if you put 500 amps through the primary, you're going to get 5 amps out of the secondary. It's pretty straightforward. One thing I would say on metering CTs, like we're talking about, 600 volt secondary metering CTs, you're almost always going to see a 5 amp secondary output. That's kind of common in the industry. Now, if you start getting into protection CTs, you start seeing some 1 amp secondaries, but generally you're going to see a 5 amp secondaries in metering CTs. That's just kind of the standards, and that's what everybody's used to. So 505, that's your linear relationship between the two. Now, meter multiplier, this is where you get your meter multiplier. So in this case, we have 500 on the primary, 5 on the secondary. Your meter multiplier is just the secondary divided by the primary, and that gets you 100. So your meter multiplier on this particular CT would be 100. All right? So it's pretty straightforward. You can see where it is on the nameplate, 500 to 5 CT. That's your ratio. You know the meter multiplier is 100. All right? That should be pretty straightforward, pretty easy to understand. Now, this is where it gets a little complicated, but it's not that complicated. Hopefully we'll make the complicated easy here. So we are talking about an IEEE standard. CTs in this world are governed by IEEE standard C5713, and the latest revision is 2016. Now, in that standard, they list 4 accuracies that you need to be concerned about in the world of CTs. There are 4 types of accuracy ratings, all right? And these are the 4 that are right here. Now, there is a 5th, but it's not in the standard. It's better than the best, and we're going to talk about that. But it is actually not even in the standard. But all of the major manufacturers make a product in that class, so we're going to talk about it. So a lot of cases, the standards are a little bit behind the times. So the standards take a while to catch up to the actual performance of manufacturers and the things that utilities want. So right now there are 4 accuracy classes in the standard, but there's a 5th that's actually being used, and we're going to talk about that 5th one. So here are the standards. This is what your accuracy is. So in this case, a 0.6 class accuracy CT means that your primary to secondary, right, that linear relationship has an accuracy of plus or minus 0.6%, right? So it can be 0.6% off of what actually is happening in that current, and to be in this class. Now, what the IEEE standard says is that when you're at 0.6%, you are not revenue grade. In other words, you should not be measuring and charging customers based on a 0.6%. It's not accurate enough to measure for revenue. It is accurate enough to get an indication of what the voltage, what the current is. So you're saying, we know what the current is, plus or minus 0.6%. That's good to know, but it's not good enough for revenue grade. The next level up is the 0.3% or 0.3 class. 0.3 class is considered revenue grade. And this is what we've called for years standard accuracy CTs. So when you hear somebody, and I'm going to talk a little bit about old timers in the industry, and not because I'm degrading older guys that have been in the industry a long time, because I'm 52. I've been doing this for a while as well. But the way we used to do things, we all thought of the 0.3 class as the best. It used to be the one that we all used. Okay. And that's the old school, that's the standard accuracy CT. So when you hear standard accuracy CT, think 0.3 class revenue grade. And that means it's plus or minus 0.3%, and it's good enough for metering. It's acceptable level for metering and charging a customer for revenue. So that's a good class. Now, IEEE then adds a couple other classes, a 0.15 high accuracy class, which is double the performance of revenue grade. And then they have a 0.15S special high accuracy class, which actually makes the window of accuracy a little bit larger. But then about 10 years ago, probably 11 years ago now, we started rolling out a new technology where we could get what's called a high accuracy extended range class. So this is actually better than the 0.15S class that you have in the IEEE standard. So I've got these red arrows here pointing. The two that you really need to concern yourself today is standard accuracy, which is the 0.3 class, and then the high accuracy extended range. Those are the two primary CTs that you're going to see used in metering these days. So you don't see too much in these two grades, and you don't see much in the 0.6. Sometimes you'll see maybe split core, or you'll see some kind of interesting applications where you can only get a 0.6 class, but typically those aren't going to be revenue grade. So usually, you're not using that in the utility as much. So the ones we got to talk about are the 0.3 class and then the high accuracy extended range class. Now, of course, we don't make this easy when we put this on a nameplate. So if you look at your nameplate, this is what you're going to see. You're going to see, and maybe I'll point up here. So you're going to see your accuracy is designated as a 0. So in this case, 0.3B-0.5. That's the way we write accuracy on metering CTs. And you can see the one on the bottom, 0.15SB-0.2. Now, it's a little confusing, but let's break it down. So the first part of this accuracy is your accuracy class. So in this case, it says 0.3. So I know that is a 0.3 revenue grade CT. That is what we call a standard accuracy CT. Then it's followed up with B-0.5. That is the burden, okay? The burden is the secondary resistance, the resistance of the secondary wiring, right? It's saying, what this is saying is that this CT can take up to 0.5 ohms of resistance on that secondary winding and still be able to do 0.3% accuracy. All right, and let's just, before I talk about that more, let's take a look at the one below. So this says a 0.15S, so we know it is a special high accuracy CT that can handle burdens up to 0.2 ohms, all right? So that's what we're looking at. Now, burden used to be a bigger deal, right? Back in the days of electromechanical meters, burden was a big deal. We had to overcome very large resistance on our secondary circuit. Now with more electronic meters, that's typically not a problem. So burden is less of an issue. And just, in my time in the industry, 15 years ago, we were always talking about burden. We were always concerned about burden. nowadays with electronic meters, we tend to not have a burden problem as much. So, so typically burden's not going to be a problem unless you have an application where maybe you have a long run of cable or some sort of an unusual application where you might have a long or large secondary circuit with high resistance. At that point, you need to think about burden. But in most cases, most applications, you'll have plenty of performance out of the CT, and you won't necessarily have to worry about burden. So when you look in the nameplate, you're going to see something like, an abbreviation for accuracy, ACCY. You're going to see the accuracy class, which is the 0.15S. Then you're going to see the burden it can handle, the burden of 0.2 ohms. So that's all you need to know of that little particular part of the nameplate. Now, I would point out that right next to it is a little hint. And we're going to get into this more, but I just want to show you that this is a little hint. It says that this CT will run 1% of rated current up to rating factor. Now, just keep that in the back of your mind, because that little statement tells me that this is actually a high accuracy extended range CT. And I'll explain that to you in a little bit, but just keep that in the back of your mind. All right. We're going to go to the next slide. Now, rating factor. This is something that is really important when it comes to CTs. A rating factor tells you the maximum current, the maximum continuous current at which this CT can operate, and it can operate and and perform at a high level, right? Not have any damage or what have you. So the way it is written as a multiplier of the nominal current. So, for example, you see my chart up here, we might have a 205 CT with a rating factor of 4. All we're saying there is that CT can handle 800 amps of continuous current without damaging the CT. So you can handle 800 on the primary, no problem. So you have this case, you have a 505 CT with a rating factor of 3. That just means we can handle continuous current of 1500 amps. This one is a 1000 to 5 CT that with a rating factor of 2, we can handle 2000 amps. That's all we're saying, is that's the maximum that you can run through that CT without causing damage. Now, I will tell you this, I probably shouldn't tell you this, but as we design CTs, we design them to perform better than that. So if you have some spikes of current that go above the rating factor, you're going to be fine. It's just the idea of continuous current. We're talking about running this thing for hours on end. You want to make sure that you don't want to exceed that rating factor. So in a 205 CT rating factor of 4, you don't want to be running that more than 800 amps because you're going to damage the CT. All right, that's the basic thing that we have to understand about rating factor. Now, the other thing I will say is that the rating factor is affected by temperature. So we're going to see that down below. So let's take a look at our nameplate. So this is the area we're talking about in the nameplate, and it says rating factor of 2 at 85 degrees Celsius. Now, right away, before I know anything else, before I even see the CT, I know that's a special CT for pad mount applications. If you remember, we went back, if you go back to the picture I showed earlier of the pad mount, the oval window style CT, and I said it was special, rated to 85 degrees C, there it is right there. So you can see that actually right on the nameplate. It's rated for 85 degrees Celsius. So it's designed for that higher elevated temperature inside of a pad mount application. All right. So this is all you're seeing, is you're saying this has a rating factor of 2 at 85 degrees. And that's telling me that I can go up to 1000 amps continuous, right? 500 times 2. I can go up to 1000 amps continuous at 85 degrees C, and I'm happy all day long. That CT will be fine, and it'll be performing at a very high level through thick and thin. All right. So you're always going to see rating factor times a temperature. All right. And I'll show you why. Let's look at the next slide. what you see here is the fact that rating factors will go down as temperature goes up. And what that's basically, and it kind of makes sense if you think about it, right? And the hotter you are in terms of an ambient temperature, the less current our CT can handle. So let's take a look at, let's just look at this chart here real quick. So we will have, say this is a 605, you have an accuracy of 0.3, a burden of 0.5. It has a rating factor of 3 at 30 degrees Celsius. So this thing can go up to 1800 amps, right? But that goes down when you get into 55 degrees C, and even further when you get to 85 degrees C. So let's take the one on the bottom, the 1000 to 5, right? At 30 degrees, you can get up to 2000 amps, right? So you can handle quite a bit of load through there at 30 degrees C. But at 55 degrees C, you're only going to be able to handle 1500 amps. So why is this important? Well, it really depends on where where your utility is located in the country, right? So Texas, I know we got people on the call from Texas. That's going to be higher ambient temperatures, right? So you got to be thinking about you're going to be running in these 55 ranges, right? So you have to be thinking about this. Now, we've got customers from Minnesota on the call, Massachusetts. You're going to have colder environments, right? So you're probably going to be thinking that I can handle the 30 degrees C type of scenarios, right? So ambient temperature is really important to think about where your product is going to be installed and what kind of ambient temperatures they're going to see, all right? So that you can size the CT correctly. So rating factor is really critical for sizing the CT because you really don't want to run above the rating factor of the CT, all right? So, and you're going to see this on a CT, like this CT that I have here, it actually has several rating factors. I don't know if you can see it. It actually lists several rating factors at different temperatures, and that's what you'll probably see. This one says it has a rating factor of 2 at 30 degrees and a rating factor of 1.5 at 55 degrees. So those typically you're going to see rating factors set up at 30 degrees, 55 degrees, and 85 degrees. And again, that's Celsius. So I don't know why we do Celsius, because we want to make things complicated, I guess. So get out your calculators and figure it out, I guess. So, all right. I can't do that in my head, by the way. Maybe some of you can. All right, so next slide. Now, so right now, there are 10 things you need to know on this nameplate, and I'm going to go through them all, and hopefully we've nailed all of them. Now, I didn't talk about some because they're common sense, but so let's take a look. This is our nameplate that you typically would see on any secondary CT out there. And here's what we started with: nominal system voltage 0.6. So you got 600 volt CT, piece of cake, right? Ratio 500 to 5, right? All right, so we know of a primary of 500 amp, we're gonna get 5 out of the secondary, and we know the meter multiplier is what? You guys can put it in the chat. What's the meter multiplier on this one? Anybody? I'm making you wake up and actually, oh, there you go. All right, I'm just gonna see if someone puts a wrong answer. Yeah, everybody got it 100. That's pretty easy. All right, excellent, excellent. So 100, that's your meter multiplier. Now let's get down here to rating factor. In this case, we have a rating factor of 2 at 85 degrees. So we know we can go to 1000 amps if we're running at 85 degrees. All right, awesome. And we also know, because it's listed at 85 degrees, we know that this is actually a pad mount application. So I'm just, you'll get to recognize that pretty easily. I'm going to go back to the slide, but I don't know how. Hold on. I got too many things here. Here we go. All right. All right. So that's your rating factor, 1000. You get to up to 1000 at 85 degrees. Now the accuracy, this is a special high accuracy, 0.15S, and it can handle burdens up to 0.2. Piece of cake, right? Now we see this statement here, 1% of rating current to rating factor. And trust me on this, you're going to learn this later, but you know that that is a higher accuracy extended range CT because of that statement. Now let's take a look at some other things. Right here you have your 10 kV BIL, all right? Now that is going to be, somehow I lost my chat window, by the way. I want to be able to see that in case you guys have questions. So let me see if I can bring that back up again. Yeah, I don't know where it is, but where's my chat? There it is. Okay, great. We'll get back going here. So, so 10 kV BIL, let me ask you, does anyone know what that means? You can put that in the chat. What is a BIL? And you'll see it on even this CT. Basic insulation level, yes. Basic insulation level, yeah. All right. What that's going to do, that tells you what it can handle for a an impulse strike or a lightning strike. So it can handle 10,000 volts of a lightning strike. Now, why didn't I talk about this too much? Because all secondary CTs have this as a rating. It's 10 kV BIL. That's how we test it in the factory. That's how we test it in the laboratory, that it makes sure it can handle a lightning strike of 10,000 volts. That's not going to change on any CT. So I don't really talk about it too much because that's going to be the same on all your secondary CTs. Now, the other things you need to know, serial number. Every manufacturer is going to give you a serial number, and that's going to be its birth certificate, right? So that's where it's going to, that's its information. That's going to have its traceability. Like for us, I can tell you everything about that CT based on that serial number. I know when it was tested. I can pull up the test reports. I can tell you where the raw materials came from. And so we can have traceability of that CT all the way up to NIST standards. So for example, if you have a customer who says, well, how do I believe that your CTs are accurate? Well, call the manufacturer, give me the serial number, and I'll give you the traceable test reports that go all the way back to the NIST standard. So that's its birth certificate. You need to know that number. And then you'll see here a style number, and that's just the manufacturer's part number, right? So if you have to, say you have 3 of these in the field and you want to add 3 more and you want the same thing, that's what you're going to order. In our case, it's a COV 0500 ANN, right? That's our part number. And the only other thing you need to worry about, this is the last thing, is down here. It just typically you'll see a data manufacturer, and then you'll see what standard it was tested to and maybe something about the vendor. So that's it. That's all that's on this nameplate. 10 things you need to know. And hopefully now that you have gone through this, you kind of have a better understanding of nameplate. And it's not that scary, right? Yes, yes, we make it complicated, but hopefully by now it's not that scary. All right. One last thing to talk about, everybody knows this, dot to pot, and if you don't know it, you know it now. You'll see on every one of these CTs, you'll see a white dot, and that's all manufacturers, and that is the dot goes towards the high potential, where the potential is coming from, your load is going to be on the other side, all right? And you'll also see, let me pop off this cap, the H1 term, the X1 terminal. This is where you're going to go out to your circuit and then come back. The X1 usually has a white line. So most people have designated. So you have a white dot to pot, and then you have a white line, and that's going to your, that goes to your meter, and then X2 completes the circuit. All right? That's it. You now understand that. You understand the CT nameplate. And if you look at a CT, you pretty much should be able to tell where it's used and how it's applied, and you can tell what type of CT it is basically by looking at it, by looking at the nameplate, hopefully, if I've done my job. Now, we're going to talk a little bit about how accuracy and rating factor play. And this is really important, okay? So this is the point. Now, if you're getting a little tired of my voice and tired of the presentation, this is the time to get up and stretch and shake it out, because this is really the most important part of the presentation, because this one piece of information I'm going to give you is going to open a lot of doors for you, and it's going to solve a lot of problems for you at your utility. I would venture to argue that 80% of CTs right now, well, okay, I'll take that back. not every utility. Some utilities have got their act together, but I would say a high majority of CTs are the wrong CTs being applied, and you're actually not measuring your commercial accounts properly. I would say a majority in the country. I was going to think 80%, but I do know some utilities that have embraced and have worked on this. But some of these CTs get put in the field and they get forgotten about, and then the loads change, right? So you might have a factory that gets shut down, and then some bar goes in there or what have you, and you're not getting the loads you used to get, and now your CTs are not performing as you expect. So this is a problem with CTs. So we're going to talk about standard accuracy CTs versus high accuracy extended range CTs. All right, so let's take a look at your standard. This is what I call the flip phone. All right, this is your standard accuracy CT. This is the CT we've been using forever and ever. All right. So this is the CT that is tried and true, just like a flip phone. It works. It's got a battery life of 10 years, right? I mean, for those of you who are old enough, phones used to be a lot more robust than they are today, but they didn't do too much. You can make a phone call, that was about it, all right? This is the old school CT, right? And so the way it operated was this way. So at the rate at your nominal current, so if this was say 100 to 5 CT at 100 amps and all the way up to your rating factor, and assume this is a rating factor of 4, so from 100 amps up to 400 amps, you're performing at plus or minus 0.3% accuracy. So you are in a metering class accuracy, right? As long as you're in this window from your nominal current up to your rating factor, you are beautiful. Life is good, right? And so the guys that have been in the industry a long time, you know this, that's your sweet spot for this CT is your nominal current up to your rating factor. That's the sweet spot. Now, what happens when you drop below the nominal current, all right? You lose half your accuracy. You go to 0.6%. And what that means is, according to the IEEE standard, is you are not supposed to use that for metering and revenue calculations. You're only in the indicating range. So when you fall down in this range, and the worst part is when you get below 10%. So if this is 100 to 5 CT, below 10 amps, the manufacturer says, I don't know what it is. I have no idea what the accuracy is. At that point, all bets are off. So what happens with a standard accuracy CT is that as current goes down, your primary current goes down, you lose your accuracy. So I don't know if those of you might been in a boat, right, or own a boat, or if you've been in a boat and you understand this. The slower speed you have on a boat, right, as you lower your speed, you lose your steerage, right? It's hard to steer a boat at slow speeds because you just don't have enough power to steer the boat. Well, that's the same thing with these CTs. As current goes down, you don't have enough power in the old way we built CTs to be able to keep that accuracy. You lose your accuracy, it starts falling apart. So everybody who has been doing this for years, the old school guys will tell you, you need a low nominal current, you want a low ratio, but you want a high rating factor. So this is the sweet. We want to make that sweet spot as big as possible. So we like the 100 to 5 amp, right? 100 to 5 CT with a rating factor of 4 because I got this big sweet spot to play with. So most old school meter techs understand this. You want a low nominal current, you want a high rating factor. So when I'm on the phone talking to customers, I immediately know they've been in the industry a long time when they want a low ratio and a high rating factor. I'm like, oh, okay. You're thinking the way we used to have CTs for years and years. You're thinking about the flip phone. Well, let me show you the new technology, all right? And I just did, all right? This is the high accuracy extended range. And what it does is it doesn't care about the amount of primary current going through it. It can run from, in this case, you're seeing from 100 amps to 400 amps, it's at double the capacity of your best performance on a standard CT. You're at 0.15 accuracy. And then when you drop down below 100, it doesn't care. It's still running at 0.5 S performance, okay? Giving you very highly accurate, all the way down, not just to 10%, but down to 1%. So at 1 amp, right? At 1 amp on the primary side, you're getting accurate performance, all right? Now, the reason that this happens is because of technology. And I don't know if you can see this up there, but that is a high accuracy extended range CT cut in half. Inside here is a new material. This material is actually called nanocrystalline steel, all right? For years and years, we used standard transformer steel to make CTs. And then about 11 years ago, we figured out, and when I say we, I mean literally we, I mean me, the team that's here at Peak Demand, we were at another manufacturer and we developed this technology. We actually put nanocrystalline steel for the first time in a metering CT, and we realized that we could take the performance all the way down to 1 amp and be highly accurate, because we don't need to have the current draw like you had with the old transformer steel. This steel was performed at a much better level, highly linear, highly accurate, all the way down to 1 amp. So you can see you're going from, you know, in a way, a flip phone to a smartphone. You can perform at a higher level in the same size package as you would for a standard accuracy CT. And in fact, if you pick up a standard accuracy CT and compare it to a high accuracy extended range, you're going to find it's lighter. The steel is actually lighter than a transformer steel. So you have light, it's lighter. You pick it up, it almost feels like a toy, and you think, well, how is this better? Well, this is how it's better. The performance of the core is much better than what we've ever had in the past. So it's like going from a flip phone to a smartphone. All right. So here's another way to look at it. These are the accuracy classes just listed a little bit differently. And the top is your standard accuracy, your 0.3 accuracy class. And just another way to look at it. So at 100% of the nominal current up to your rating factor, you're going to be at 0.3%, right? That's your sweet spot for that CT. When you fall below the nominal current, you lose half your accuracy. You go to 0.6. You're only indicating, whoops, not sure why I was doing it. You're only in the indicating class, and then until you get down to 10%, then you lose everything. So old school guys would say we got to keep in that blue range, right? And, you know, IEEE standards came up with some other different ideas, but again, the one that everybody's using today, ourselves, ABB, RITS, you can get the high accuracy extended range, and that is you're performing at 0.15%, that orange range, from 1% of your nominal current all the way up to your rating factor. See this big wide window of very high accurate performance. So you would be surprised. You would think that everybody has made the switch to high accuracy extended range right now. And the truth of the matter is that, how do I say this? Utilities are conservative, and you don't believe it. In fact, every utility, when we were doing this in the early days, everybody wanted to do independent testing, and they wanted to verify for them. They wanted to verify that it worked for themselves, right? They didn't want to believe us, the manufacturer, and everyone came up with the same conclusion, that these do perform at that high level. We just had one major IOU out west test our CTs, and he said, I've never seen, in 40 years, I've never seen a CT perform like this. And I'd like to say that it's our skill, but it's really the technology. It's this nanocrystalline steel. It performs very well in these type of applications. All right. So let's talk a little bit about how these new CTs kind of help your business and help your utility. One of the big things is, since you have this wide window of very high performance, you don't have to carry as many ratios. Now, I'm doing a bid right now for a very large utility, um, and I'm looking at their usage, and they have every ratio under the sun, just like you might have down below here. You got 100 to 5, a 200 to 5, a 400 to 5, an 800 to 5, and 1,000 to 5. And because that's what's in the standard, that's what they're used to. They've been doing this for 40 years, right, or 50 years. And we know the old school guys say we got to have low ratio with a high rating factor. That's the way you perform, right? And so take a look at the blue, the dark blue. That's the sweet spot of these CTs, of the various CTs, standard accuracy CTs. And so it's difficult to try to figure out what CT do I put in what application, right? So you might determine and say, well, okay, this is a right now I've done all my studies, and this is a 600 amp application, right? So say your current is right about here, your standard load, right? So you could easily use a 200 to 5, right? With a rating factor. This one's got a rating factor of 4. You could use a 400 to 5, right? So you'd be in those sweet spots. That's great, but you couldn't use this CT because it would be undersized, and you couldn't use an 800 to 5 because it'd be oversized. But you could choose one of these two. Great. That's what you would do. You say, okay, well, I want a 200 to 5 in this application. Boom. All right. Now what happens, right? Say that that this application starts using less and less load. It starts falling down. You might find yourself below 200 amp, right? And do you still have the right size? And again, the other thing is most studies are done in a static way. So that 600 amp we talked about, that might be at one point in a day. What is it on the weekends? What is it at night, right? It might be down in this range where you're losing it, right? But again, you're doing this analysis trying to pick the right CT. Well, if you had the CT above, which is a 600 to 5 rating factor of 2, you could handle from 6 amps to 1,200 amps with without ever changing the CT. So you can handle all those loads, anything from 6 to 1,200 amp, you can handle without having a separate ratio. But here's the thing. When I talk to old school guys, they're like 600 to 5 with a rating factor of 2, that's not going to work. And why are they saying that? Well, because they're thinking, in the old school way of like the flip phone style of CT, and that is going to give you, they're thinking it would only perform from 600 to 1,200 amps. But in fact, because it is a high accuracy extended range, it goes all the way down to 6 amps. So it's changing our way of thinking. And when we do this, we can carry less inventory. We don't have to carry all these styles, right? We have one product we call the Holy Grail. And I call it the Holy Grail because I worked on it for years at another company, and I finally was able to do it at this company. And it's a 500 to 5 CT with a rating factor of 4. And what that means is it can go from 5 amps to 2,000 amps at a 0.15% accuracy. Why I like that CT is that and it's used in an overhead application, and we have a number of customers that they've gotten rid of all of their inventory, and they just stock the 500 to 5 rating factor of 4, and that's what they use across the board because one CT can replace all the other ratios. So my point being is that you can reduce your number of SKUs you carry, number of ratios you have to carry if you apply this kind of methodology, this kind of thinking. All right. So another way that we get benefits is that we get a more accurate. First of all, you've got double the accuracy of even your best, your sweet spot. You get double the accuracy with the high accuracy extended range, and you get it over a larger window, right? So again, what utilities have found as they've done independent testing is that they're picking up the loads on the low end that they might have missed out using these other CTs. So especially when you get down into the real low ranges. So take a look at, say you have this is a 1,000 to 5 with a rating factor of 1.2, right? What happens when you drop down below 100 amps? So, and it's not unlikely to have an application where you might have 1,200 amps during the day and less than 100 amps at night. Well, you lose that. You don't capture that revenue at the low end. With the high accuracy extended range, you get the whole window, very large window of very high performance. So what we found and what other utilities have found is that they're picking up that load at the low end. So they actually get more revenue capture. And the other thing that's just it's kind of a funny thing. No, not a funny thing if it happens to you, but meter multiplier, right? I've talked to plenty of people in the utility space where they have a meter multiplier wrong, and that creates a billing error, and that creates a problem with the customer. And the challenge is if you are using all these various ratios, you have all sorts of different meter multipliers. And so you got to make sure your paperwork is right so you apply the right meter multiplier for each of your customers. Well, when you standardize on one ratio, and I like the 500 to 5 rating factor of 4, the holy grail, because it has a meter multiplier of 100, and it's sort of it's easy math, right? And it's less chance. When you get to 120, maybe you have a math error, I don't know. But I like the fact that you have less meter multipliers, so you have less chance of making a mistake in a billing error calculation. So again, just one of those unsung benefits of having this wider range window. All right, and I'll show you one example. We had a customer that did some testing. They took and they put standard accuracy CTs and high accuracy CTs in line with each other, and they measured 3 different types of loads: a large church, a small church, and a ball field, all sorts of different applications. And what they discovered is because they were picking up the low end more, depending on the actual load, they would be picking up 0.25 to 1% more revenue with that application. So you're picking up the low end, you're picking up that stuff that the other CTs miss, and so you end up picking up more revenue. So you actually gain, and what we found is anywhere from 0.25% to 1% more revenue is what we're seeing from the people that have done their independent testing. So you do pick up more revenue because you're picking up on the low end. I see a few questions coming in. I'm going to answer those shortly. So I'm going to keep going because we're almost done. Some testimonials. All right, so let me ask you a question and then you can ask me questions. So I'm going to give you just test your knowledge here. So for a 605 CT with a rating factor of 4, what is the most current you can put through that CT? What is its maximum current level on the primary side? This is where there we go. Here's some answers coming in. Yeah, everybody's got it, 2,400. Yes. Okay, very good. That's the most that CT can handle, right? And it won't be damaged. Next question. At 2,400 amps on the primary, how many amps would be on the secondary? What's being sent to the meter? Adam was right on it. 20. You guys are good. No, not. All right. 20 amps. Now, let me tell you how I do the math, all right? 605, what's the meter multiplier? That's not on here, but what's the meter multiplier for a 605 ratio CT? Yeah, it's 120. Yep, 120. All right. So to determine the secondary amp, if you know the primary amp, you're gonna divide your primary amperage 2,400 by the meter multiplier. So in this case, it's 120. So 2,400 divided by 120, that's where you get your 20 amps. Everybody good with that? All right. All right. So with a high accuracy extended range CT, do you need a low ratio and a high rating factor to get a wide range of accuracy? Yes or no? No. Nope. Nope. All right. Good. Excellent. You guys are good at this. All right. With the high accuracy CT, a high accuracy extended range CT, will you get more revenue for the utility? Chris, I love it. Probably. Yes. Probably is a good answer. If the meter is capable, yeah, absolutely. So yes. So, and I say probably, and I think it's a good answer because it depends on the application. So if you have a variable load, like those ones we talked about, churches, ballparks, things that are going to be at one level at one part of the day, one level another, you're more likely to gain that revenue gain than if you have a static load that's always, 800 amps and never changes much. So I think it depends on that. Now, one beautiful thing about the high accuracy extended range is this: when you have a new building application, typically you get you're told what the load is going to be, right? And so you size CTs based on what you think the load is going to be. Well, I think from the feedback I've heard is that in most cases, that load is never achieved, right? They never get to that level that you plan for. And so with the high accuracy extended range CT, you buy it, and even if the load is not where you think it is going to be, if say it's lower, you're still going to be sized correctly for that application. So you don't have to have your sweet spot is a lot larger on these CTs. So that's one of the things that makes them so good. So what's another benefit to high accuracy extended range CT? This is extra credit. It's not multiple choice. So what do you think? Reduced inventory. Yeah, less stock. Yep. Yeah. So, okay, good stuff. All right. So, and lower inventory levels, right? All right. So now it's up to you. I am going to take questions. I know we have a very little time left, but I'll stay to answer questions. So there were some questions earlier that I think got buried, but if you have questions now, this is a good time to do it. I'll do my best to answer them. What determines your rating factor? Okay, so your rating factor is going to be that high temperature that you can, the highest temperature that can achieve. So it's dependent on a lot of things, but it's how well the insulation and the core performance. We actually test these. So if you think about it, you don't want a rating factor of more than 4. 4 is the highest it can be, and 4, because a rating factor of 4 gives you 20 amps on the output. Typically 20 amps on the secondary is the most you're ever going to put into a meter. So we test it to see if it can get to a rating factor of 4, and you do it just by going to the lab and see if it doesn't damage the core. So you work on that, but ideally rating factor 4 is the highest you can get. So we try to get as high a rating factor as we can. Yes, you can get a copy of the PowerPoint. I will send that to you. We'll actually make a video of this available to everybody as well, so you'll be able to share it as well. Okay, yeah, I will get copies of the presentation, sure, no problem. There were some earlier questions that I sort of skipped over because I was busy talking. How many of you are, yes, okay, I'll send out copies to everybody. How many of you have heard of peak demand before this meeting, this webinar? Anybody heard of us? Nope. Yes. Did not. Okay, Andy. We bought from you. Okay, Jeremy. When are we going to make primary meeting? We're working on it. We're working on our primary designs here. No, a lot of no's. Good, excellent, excellent. There was one question that was in there, but it got buried, and I apologize. I was not quick enough to read it. If you want to write that again. What level of secondary current output will a high accuracy extended range drive below the average revenue meter? I'm not sure. Level of secondary output will a high accuracy drive below? Well, it's a hard, I don't know how to answer that question. So yeah, you're right in that. So for example, if you have a 100, we have a 305 in this style, right? 305, it'll go down to 1%. So it'll go down to 3 amps on the primary. So it'll put out, it would be 3 amps divided by whatever the meter multiplier would be for that. And so the question may be, can the meter handle that low of a load going through there? I don't know the answer to that question, but we'd be able to put out that just at 3 amps on the primary. So if you have a 505 high accuracy, whoa, slow down, is great to drive on 1 amp, but would you truly capture this resolution? Yeah, so yeah, it depends on your meter. So there are some meters that can handle it, there's some that can't, as I understand it. I'm not necessarily a meter expert, but we've got guys that have been using meters that can drive it down to that low position. Would a CT melt down or just not measure accuracy? So yeah, no, it eventually will melt down if you're running for long periods of time above your rating factor. So that's your risk. That's why you don't want to perform too high above that. Yeah, I'm available to give this presentation to individual utilities. Yes, absolutely. 0.25 output secondary and a CT. Okay, cool. Thank you for the class. Gotta go. All right, thanks, Adam. All right, so let me go back to one slide real quick because I don't know where it is. All right. Last slide I'll show to you is this one. So we're, as I mentioned, we're operational. We are making CTs cutouts every day right here. 90% of our orders, of our CT orders ship in 24 hours. That's our difference. So when we started this company, we didn't want the same 6 to 8 weeks like everybody else has. So we do 90% of our orders ship in 24 hours. So there's our contact information. Give us a call. We can ship very quickly, and we are in operation right now. And if you haven't bought from us yet, I am offering just to you guys that are on the call. So you just have to reference this, that you were on the call, is that we're offering free shipping for all orders for the month of April, just during this COVID crisis. So just mention that you're on the webinar and you'll get free shipping. So typically we say $2,000 and you get free shipping, but we're allowing smaller orders as people want to try us out right now. Okay, so go to our website, learn more about us. It's peakdemand.com, and down at the bottom you can actually see there's a link for we have local sales reps in your area. You can call on them and get in more information. They'll come out and visit, or you can give us a call here at these contact information below, and we'll take care of you. That's it for today. Thank you very much, and I appreciate all your attention, and we will do this again. So if you have someone in your utility that hasn't seen it and you want them to see it, this is a good, we'll run it again and you can share that information. Thank you very much. Take care.